What is up, Flutter devs? Today we begin our journey to port processing over to Flutter. That's going to begin with us looking at what it means for us to port it. What is it that we're porting over? We'll also then get started with the initialization of the repository, and we'll see what initial baby steps we can take together to start us down this path to port processing over to Flutter. Let's jump over to the desktop and take a look at things. Let's begin with a trip over to the processing website. If you want to get the formal introduction to what processing is, you can go to processing.org. Right here on the front page, I'll read you a little description. I've read this in a previous video, but I'll read it again for those of you who didn't watch that previous video. Processing is a flexible software sketchbook and a language for learning how to code within the context of the visual arts. Since 2001, processing has promoted software literacy within the visual arts and visual literacy within technology. There are tens of thousands of students, artists, designers, researchers, and hobbyists who use processing for learning and prototyping. Again, if you've seen my previous videos, this is pretty much the message that I've given you, and there it is right in the middle of the screen. And right here we have a video created by Dan, whose channel is The Coding Train. You can find him on YouTube over at The Coding Train. And I emailed Dan and I said, you don't know me, but I think I'm going to port processing over to Flutter, and I would like to shamelessly copy a whole bunch of your content to use it with the Flutter version of processing. I'd like to copy all the hard work that you've done in a bunch of your videos on my channel using the Flutter version of processing. How do you feel about that? And he said, thanks for asking, go for it, have fun, and feel free to talk to us over on the Coding Train about your progress. So he was very nice about that. We'll see if he still feels great about it as I shamelessly just replicate all of his hard work. But for now, that's the direction we're going to go. And the cool thing there is, as we start porting processing over to Flutter, sure, we'll do little widget tests and golden tests and things like that, but you want to keep in mind the concept of a stress test. Implementing something is more than just a sea of primitives. Obviously, people use processing to accomplish goals, like many of the very cool visual effects on the Coding Train YouTube channel, and I recommend you all go check that out if you haven't already. We need to make sure that as we try to create APIs inspired by processing, that developers who use this tool can accomplish the same kinds of visual results that Dan is able to accomplish on his channel. And so the idea is, if we can essentially take various videos that he's created and redo the same thing using the Flutter version of processing, we are putting our version of processing through a stress test to ensure that it really can do what it's supposed to be able to do. That's something to look forward to. I don't know when we'll get there. We got to lay the groundwork, but eventually I hope to create those kinds of videos. Now, all that said, let's start getting into the meat of this issue a little bit. Here is the processing.org reference. This is the reference. You will immediately see a bunch of, well, some of this is kind of syntax reference, but most of what you're looking at are procedures that are implemented in processing. I guess let's take some groups and look through them. 2D primitives. Arc, circle, ellipse, line, point, quad, rect, square, triangle. Each of these procedures will draw the associated line, curve, or shape on the screen. We need to implement our own version of arc, circle, ellipse, line, point, quad, rect, square, and triangle, because we would like Flutter developers to be able to draw these exact same things in a very similar way on a Flutter UI within a Flutter widget. Setting, here's the background color. Here's how you clear the background. Color mode. Fill, what's the fill of the shapes that you draw? Or no fill if you don't want to draw them. No stroke, stroke. Now, one interesting thing to notice here, those of you who have been working a lot with Flutter and you are super familiar with the widget tree and you're all about declarative user interfaces, and my name is super declarative. You know I'm all about the declarative UI. But processing is an unabashedly imperative API. You are invoking this. You set a fill color for a while, and then you get rid of the fill for a while, and then you call fill again. It just depends on what you're trying to draw. But you're constantly manipulating the state of the painting system. Processing works this way throughout. Remember that processing came around in 2001. Declarative UI was not a particularly popular or well-explored concept in 2001. In 2001, everything you did was imperative, and so it should be no surprise that processing itself is imperative. But also, processing is used as an educational tool, not just to educate people about graphics primitives or graphics programming, but actually to educate some people about programming in general. And programming in general is never declarative. Programming in general, your Turing complete programming languages, this is literally about sending instructions to a CPU, accessing memory addresses, and manipulating values. General programming is always imperative. Only when you have underlying implementations can you abstract things into declarations. This is why the SQL database language, the standard query language, can only exist in conjunction with a database implementation. That database implementation is imperative. And Flutter's widget system, the declarative widgets that you use, they can only exist alongside elements, render objects, and an entire compositing system. Now, the compositing system also has some declarative pieces, but elements are imperative, render objects are imperative, and most of the compositing system is imperative. If you're going to teach somebody the fundamentals of programming, you have to do it in an imperative way. Otherwise, they'll never learn about what's happening in memory, what's happening in the CPU, etc. Again, overarching point is acknowledge that everything here is an imperative call. Arc does a thing, then circle does a thing, then ellipse does a thing. Even things like fill and stroke. You put the drawing system in a certain painting mode, do your work, then you put it in a different painting mode, and you do more work. Similarly here, creating and reading. The alpha value, blue, brightness, color, green. And actually these, let's open these up. I don't know if this is setting or retrieving the blue value. Extracts the blue value from a color. Okay, so in this is another interesting thing that we're going to deal with as we bring processing over to Dart and over to Flutter. You see, Dart and Flutter have introduced this really great practice of giving you a bunch of awesome primitives. For those of you who have not spent time outside of Flutter in terms of graphics programming, you may not realize that there's not always a color object available to you that tells you anything and everything that you want to know about colors. Right here where we're getting the blue value, and actually this might be one of the places in Flutter where you actually would need to do a little bit of work. Let me choose a better description of what I'm trying to explain to you here. Let's try brightness. Brightness is a function that you call in processing. You give it a color and it computes the brightness of the color and gives that back to you. In Flutter, what you do is you would create an HSB color, hue, saturation, brightness color. This is a primitive that's available for you out of the box. And when you create an HSB color, one of the components, the B, is brightness. And so you just say color.brightness, and there's your brightness. So we don't really need to implement this method, or this function. It's already available on a color object, an HSB color object. Let's look at what else we got here. So now blue might be nice. Maybe that's something we can provide on top of Flutter, because I don't remember right now the entire API for colors. Let's find out. Let's just go look. Flutter color API. Here's the color class. And we don't want constants. We want properties. Where are the properties here? Guess there aren't really any. Oh, so this is colors plural. We want colors singular. And so actually, no, blue is available to us. If you have a regular color object in Flutter, you can say .blue, and it's going to give you the amount of blue expressed as an integer between a probably 0 and 255, 8-bit value. This blue function here, I believe, does the same thing. Let's see. Slightly different. Okay, extracts the blue value from a color scaled to match the current color mode. Now, I don't know off the top of my head what the color mode does, but the value is always returned as a float. That's a little different. In Flutter, you're going to get an 8-bit integer, so 0 to 255, I believe. I can never remember the bits to base 2 to base 10 and all that, but I believe it's 0 to 255. Here you get a float, which is probably between 0 and 1, if I had to guess. So not quite the same, but something we're going to have to ask ourselves as we go through this process. Is it worth us implementing this? If you can already get blue as an integer from any given color, should we create another similar function that gives you a float value and scales it by some color mode? I don't know. Maybe. Again, the stress tests will help us with this. If we start trying to create things similar to the coding train and it's more work for us because we don't have this procedure or this function, then sure, we can go create it. But this is the kind of thing that we probably shouldn't create until we find a reason to create it, because it may not be necessary in the scheme of things. The second thing is that this blue function is a global function, like all the other stuff that you're seeing here in processing. Just anywhere in your code, you can just say blue, just blue right there. And you pass in your color and it gives you back the amount of blue. Well, is that even, should we even use that paradigm? Or should we define an extension method on the color class that returns this information? These are the questions that we will begin to tackle over time. Coming back here to the reference. This will be an interesting area to tackle eventually, which is the ability to create images and edit images. What does that mean for us from a Flutter context? Is it just an array of pixels? Do we need to do something more sophisticated? That's going to be one of the at least intermediate complicated things for us to figure out, because, you know, we've got to really take into account some details. And even once we create an image, like pimage here is a class. So pimage can do stuff. You'll see here, pimage can return an array of pixels because at the end of the day, every bitmap image is nothing more than an array of pixels. It also has a width and a height. And apparently these are the behaviors that every image supports. Load pixels, update pixels, resize. You can, let's see, read the color of any pixel or grabs a rectangle of pixels. Set is essentially the converse to that. Mask, so mask parts of an image with another image as an alpha channel. Filter, copy, blend, save. These are all things we need to figure out how to do. Either we need to find existing parts of Flutter that do them equally well, or we need to implement this kind of capability. Or we might find out it's not possible without changes to Flutter. I don't know. We'll see. 3D primitives, this is where we get into very interesting space. Some of this will be doable because most 3D is just transformation matrices on what would otherwise kind of be two-dimensional constructs. However, and I don't know where the part I'm looking for is now, but oh, here we go, textures. Now, textures are things that exist inside the GPU, and textures get put through shaders to figure out how to paint three-dimensional artifacts. This might be impossible currently, and we'll get in eventually when we get there, we'll get into why it's impossible or why it may be impossible, but this might be an area where we essentially have to file an issue with the Flutter project, or we have to join an existing issue and we need to make clear what support we need here, and we have to kind of hope that the Flutter team can deliver that. All right, let's back out here for a second, and let's just look at all this stuff here. All this stuff. For the most part, we want a Flutter version of every one of these commands and properties. The exceptions are the things that Flutter already does well. First of all, we're not implementing a language. We don't need to create relational operators. We don't need to implement for loops and while loops. We don't need to implement conditionals. So a whole bunch of stuff right here is just immediately off the table. We don't care. Then let's take something like trigonometry. We know that sine, cosine, tangent are available in the standard Dart math package. We don't need to re-implement those. We also have atan and atan2, I believe. I don't know if we have a cosine and a sine, which is arc, cosine, arc, sine. We probably do. Now, degrees and radians, I've actually, some of you may know that I've created an entire Flutter or entire Dart geometry package. I don't want to bring that in here. I don't want to create an unnecessary dependency, but these are some questions we'll have to ask when we get to degrees and radians. If we're going to flip between them, either we're going to re-implement some of my geometry package, or maybe I will go ahead and make it a dependency. We'll see. But some of this we'll need, some of this we won't. But otherwise, everything here that is not already in Dart or Flutter, ideally, we create a Flutter version of it so that any Flutter developer can create any processing style sketch or effect that they can think of. All of that said, all of this prep, all of this notion of what we're doing, let's go ahead and start taking some baby steps to do it. I have Android Studio open here, and what I have already done is I've created a new Flutter package. This is nothing more than going through the wizard that sets up the new package. I've called it Flutter_processing. Here's the pub spec. We have the name of the package. We have a description, which has not been set. I don't know what description makes sense. For now, we can say, let's see. This is one of those paralyzing decisions. What would make sense for this? A Flutter version of processing. I don't know. We can always change it later. And I think I'll set the initial version to 010. And the idea here is that as we make changes, it'll be +1, +2, +3, +4. As we make additions, and then as we make minor modifications, we'll increment this number here. And then as we make breaking changes during early development, we'll change this number here. Until we get to the first stable release, this first number is 0. And the idea that I'm using here is that we take these three numbers and we essentially shift them all one to the right in terms of what is known as semantic versioning. Semantic versioning. I'll let you look that up on your own. But the idea is that each of these digits or each of these sub numbers should change for different reasons. Typically, it works like this. This will be the first stable version. Anytime that anything changes, anytime you release an update, assuming that you don't break anything, that you just added something, or that's pretty much the only change you can make without technically breaking what people already have. So let's say that you just add a new function that doesn't break anything else. Well, then you would release a new version and it would be 1.0.1 because you didn't break anything, you just added something. And this next part I might get a little wrong, but I think if you have a minor breaking change, or maybe you've added something that is not backwards compatible, or so anyways, think minor. Think of a minor change that has an impact on people who are using this, but it's not going to like hose everybody. It's a little change to this implementation here, or a minor signature change over there. Then you'll come in and instead of 1.0.1, it'll be 1.1.0. This lets people know something changed that had an impact, but it's not a major breaking change. It's also not nothing. It does have an impact on people who are using it, but it's relatively minor. And again, there's a definition for specifically what that means. I'm butchering it right now. I will try to base it on the actual definition for semantic versioning. But then the big one is when we go from 1 to 2 up here. It doesn't mean that everything's different, but it means that if you were using version 1, we may have broken you with changes that were added. And so we're going to version 2. You cannot safely upgrade from version 1 to version 2. You need to actually go in and revalidate all your code. That's the big one. When you go from 1 to 2, 2 to 3, when that first number changes, it's a big deal. But now, why did I have 0.1.0? And you can kind of think of it like this for right now. Before you get to the first stable version, when you're just hacking along and you're just adding features as quickly as you can and you haven't really figured out how this whole project should be structured, take all 3 numbers and move them over by 1. So keep this first one at 0, and then the second number is your major version number. The third one is your, I think maybe minor version number. And then this +1 over here, this dangling number on the end, this is your kind of like change number, or like anything that you change. Anytime you ever release a new version, at least this last one, this last number needs to get incremented. What we've done is we've taken the 3 semantic version numbers and we push them over by 1. And it'll be that way until we get to version 1.0, and then we shift them back and we use the regular semantic versioning scheme. The reason this is important is because people will use this package in their projects. If you've worked with Flutter, you know this. You go into PubSpec, you put some dependency in there, and then next to the dependency, you put some version. So there will be apps that will come in and they will say, we want to use Flutter Processing version 0.1.3 +5, let's say. But actually, most people won't put exactly this version in. They'll put a little caret right here. And what that caret does is it says, give me at least version 0.1.3 +5 or any newer version that is compatible. Give me the newest version that is compatible with this version of Flutter Processing. That decision, like PubDev does not inspect the code in all of the packages. PubDev just interprets the version number. PubDev says, okay, each one of these numbers means something. So if we release version +8, that's what we're going to get. Like this little snippet right here, it might actually give you, here's the comment syntax. You might actually get 0.1.3 +8. You said 0.135. What you got was 0.138. Why? Because 0.138 is newer, but it does everything that this version did. So it's safe to upgrade you. That's what this caret means. But if you don't stick to the rules of these numbers, then all the developers that use this caret, they're going to get versions of your package that just are broken. They're going to run pub get and they're going to get a broken version and they're not going to understand why. Why is it broken? It's because in that case, the actual version they got was supposed to be compatible because you said it was compatible. You told PubDev with these numbers that it was compatible, but it wasn't compatible and you broke your customers. And that's why I have taken all this time to explain this. These are not random numbers. I'll fill in the author and homepage later. We don't need to do that now. Every package you create is going to have a PubSpec file that has this metadata information that's needed to actually put it up on PubDev. There's also a README here, a very quick introduction. And then of course, any of you who would like to help support this effort financially, you can right here. The interesting thing about the README file is everything that comes next. I went over here and I pretty much took every one of these procedures and constants that I think we want to port, and I've put them in this README file. All this stuff. So as we implement various sets of these behaviors, we will check off all of these items in the README file. This is just one convenient place to keep track of our progress, and you can see how much progress we have to go. There's a lot of stuff here. So this is like our massive grocery list. And starting mostly in the next video, we will begin to go ahead and work on these and check them off. But that's in the README file in case you want to go look that up. Now, any open source project you create needs to have a license file, and you need to think about the license. I default to MIT licenses because they're highly permissive. You can pretty much use this code however, wherever, whenever you want. If you choose anything other than an MIT or maybe an Apache 2 license, there are probably details that matter. You need to think about it. And while there are a lot of independent developers that don't necessarily take these licenses seriously, they should, but they don't. What you really want to think about is, do I ever want an educational institution to use my code? Do I ever want a serious company to use my code? Do I ever want a nonprofit organization to use my code? These organizations care immensely about licenses. They won't even go past the license if it's not something permissive enough for them. Somebody will say, hey, you should really use this project. And then someone in the area of compliance for those institutions will say, okay, what's the license? They'll double click this file and say, nope, can't do it. You went with a GPL license, can't use it. You went with a license that has far too much in terms of requirements. We aren't even going to consider it. And at that point, it doesn't matter how great your code is. The places that matter won't necessarily use it because of your license. There's a change log here. This is auto-generated. Someday I might fill this in. Change logs are kind of tedious to keep up with. We'll see how much that matters. It only matters for us more towards version 1 because almost no one's going to be using this until we get to that stability place. Flutter_processing.dart is currently a blank file. This file was generated for us. This is where everything's going. This is the file that you would import in your project if you're using this package. And I think that it should have something like this. I can't remember if it takes a string or what. I think maybe it does take a string. I don't know. This line, I actually accidentally deleted already. Let me go look that up right now. So that's a Dart package library command. I don't even know how to look it up. So this is for creating a Dart package. This right here is what most of the file is going to look like, where we export pieces of our source code to whatever developer is using it. We'll see that later. But I was looking for the line that actually says what the package is, which again is auto-generated, but I deleted it. I'll find it later. For now, it'll just be blank. But there is one thing that I want to do with this project while we're here in this video. We don't have any example project inside of this project. And we should. If you're going to create a Flutter package, you should have a project within your package that shows people how to use your package. So let's come to the terminal here. This terminal is inside the root directory of this of this Flutter processing package. And we're going to say Flutter create. The template is going to be app, and we're going to put it into a directory called example that does not yet exist, but it will. So let's run that. Okay, it's doing its thing. All right, come over here, and here is an example directory. The next thing that I'm going to do is I'm going to come up here to add configuration in Android Studio, and I'm going to add a Flutter run configuration called example. Normally, when you create a Flutter app, it's already configured for you to run. But we've created an app within a Flutter package. And it didn't exist initially. We need to tell Android Studio where to find the Dart entry point for our run configuration called example. I'm going to click this folder button. I'm going to go into the project. So here's Flutter Processing. Now here's the example project. Go into lib, open up, or not open up, but reference main. That's the entry point. And then we'll say OK. And notice that now we have a run configuration that will launch the example app. Let's select Mac OS. On my computer, I have enabled Mac desktop support. So we're going to build this brand new example app for Mac. I think it generated that directory. Yeah, see right here we have Mac OS. Let's go ahead and run. It's going to run some pod install stuff. Still building. Turns out that long build times are not unique to Android and iOS apps. Apparently, they also exist for Mac desktop apps. Come on. Come on. Thankfully, we have hot reload. So once this happens, then we're good to go. Okay, here it is. This is our desktop app. And we have our usual tap to add to this counter thing. And we can resize the window, which in somewhat recent time, over the last few months, has been improved. It used to flash a lot because there were some synchronization issues, but now it's a very beautiful resizing of the window. This is a full-fledged desktop app that we've built and that we're running here. In the next video, we're going to come and clear out all this nonsense in here that we don't need. And we're going to create the concept of a processing widget, and then we're going to start implementing. But this is our test bed. This is where we try different things with our processing implementation and make sure they show up here. Eventually, we might turn this into a kind of demo catalog. For the time being, we're just going to come in here, try a thing, go to the next thing, replace what was in here with the new thing. We're just going to use this as a hacking space. So let's exit out of that. We know our example app builds and runs. I'm going to do one more thing, though. I don't expect to mess with this on mobile anytime soon, meaning Android and iOS deployments. I just don't care about that. And so there's no need, in my opinion, or even web for that matter. Web I might create later, but there's no need to clutter up the example app with an Android directory, iOS directory, and web directory at this moment in time. Once the Mac version of this implementation is starting to look pretty good, then I'll probably add web, because web is a very obvious place where people would like to do these kinds of things. And then once Mac and web look really good, then I'll worry about bringing iOS and Android back. But until then, that's a whole bunch of files that are sitting there taking up space that we don't need, and who knows when we'll actually need them. So I'm going to change directory into the example directory, and then I'm going to remove the Android project, I'm going to remove the iOS project, and I'm going to remove the web project. If we let it refresh over here, you'll notice those directories are just gone, and now those projects don't exist. Now we have these red squigglies under integration tests, and if I open this folder or this file, notice that it goes away. And if I open up this one, it goes away. There's some kind of dependency synchronization that doesn't seem to be working correctly for integration test. Those errors weren't real, so the squigglies are now gone, and we're good to go. With these changes, I am on a branch. I am on a branch called Setup Example Project, which is what we just did. You'll notice that I did modify the pubspec file, and it says that the current directory is untracked. That's because I'm in the example directory. Let me move up one. Let me do git status again. Pubspec is changed, and the example directory is all new. So let me say git add all. We'll do a git status again. And now we're adding all of these files. These are all the files in the example app that we just created. And actually, let me do one more thing. By default, your run configurations are not added to version control. To do that, we have to say store as project file. Done. Say OK, and then say get status again. And notice that this .run directory, this hidden directory, is suddenly there. That's what stores the run configuration, so that after I commit this, you can pull this down in your Android Studio, and you will also have the example run configuration, which is what we want. I will commit this. Created example project does not do anything. And then git push origin. What did I even call this thing? I don't know what I called. I already forgot what I called this branch. Git push origin setup example project. Do that. I already have a repo set up for this. It's on my GitHub at Flutter_processing. I'll put up the PR for that and merge it in outside this video. You don't need to watch it. But let's quickly recap what we've done together here to get this effort started. I've shown you the massive sea of procedures that we want to implement. I have shown you that those are replicated in the root level README file, all of these procedures here. Together, we created this example project, which is our test bed. This is where we're going to hack, where we're going to see what we're actually creating as we create it. And as we begin creating things for this package, they will go in this lib directory. And once we get there, I will add the correct command that's supposed to exist in Flutter Processing. This file here will export all of our procedures and our widgets to the developers that are using this package. Starting in the next video, we are going to talk about what it means to create a processing widget. What should that widget look like? How should it be used? And we will probably take 1 or 2 initial procedures to implement to prove that our approach to a processing widget holds water. That's how this overall process is going to work. We are going to take little piece after little piece, implement it in the most obvious way possible. Then eventually we're going to run into something that we can't implement, and it's going to force us to reconsider everything. And then we're going to refactor to support the new capability. And then we're going to keep going. We are also going to make heavy use of golden tests, which are screenshot tests. That way, once we've implemented something, we can refactor all we want, and we know it still works because we have golden tests. Next video, we begin by defining the general concept of a processing widget, which opens the door to implementing all of those procedures to come, and I'll see you then.